Hello class, let's look at this third and final graph that you should have tried, and we'll check it out and see what's going on. So this time we're going to graph a secant function, and it's a fairly complex one, I suppose. So let's go ahead and see if there's any transformations we need to separate first. And I think there are this time. Let me switch to my blue. So this time I think we need to do some factoring. There is in fact a transformation we need to deal with first. So inside I'm going to factor that secant to pull this 4 out, because I need to see how far it's actually going to the right. It's going to the right not by pi but by something else. So if I pull 4 out of pi, then I think I'm going to have pi over 4 left. Is that right? Let's see. So the way you can check is you can actually distribute back and see if you get what you had, right? If you're unsure about factoring, you can always distribute back. So what would that be? That would be 4x, and then we'd have minus 4 pi over 4. Those would cancel out, so we'd have 4x minus pi. Okay, so that's correct. All right, so let's go back and grab blue again. So now we can see all the true transformations. The amplitude, there's really none, but we also want to be thinking about the guide. So our guide, we'll say, does have an amplitude. Our guide is going to be a cosine, right? It's going to be, in fact, cosine with all that the other transformations on there. So the guide is cosine, and it has an amplitude of 2. Okay? The period of this function or of the guide is going to be 2 pi to start out with, since it comes from a cosine, and we're going to go 2 pi divided by that 4. So that's going to mean that we have pi over 2 left. So there's going to be a period of pi over 2. It's going to wave and finish one wave cycle every pi over 2. The phase shift we correctly identified by doing our factoring up here. That's going to be to the right a little bit, and that's going to be to the right by pi over 4. Okay, what other transformations do we have? I think we covered our 4, our pi over 4, our guide issue. We're also going to have a vertical flip, so we're going to reflect or flip vertically. So reflect over the x-axis. I sometimes don't like to say x-axis because people get confused about x versus y, and I don't really insist that you draw those anymore. I do insist that you not mess this issue up, though. You can't flip it one way when it's supposed to be the other way. That's a big mistake. So make sure you didn't. If it was a flip over the y-axis, the x or the inside would have a negative on it. Remember, inside is horizontal in terms of transformation nomenclature or transformation issues. Okay. So let's go ahead and graph the guide function first. I'll graph the guide function in blue. So we don't have any up or down, so I'm not going to start with that. If we did, I would definitely start there. I'm going to be right by pi over 4. It's a cosine function with an amplitude of 2. So cosine starts in the middle. Let's scale this by pi over 4, shall we? Because our period's pi over 2, and we've also got a phase shift of that much. So you know what? I'm going to say this is pi over 4, just to get myself going here. We'll say this is a half. We'll say this is a 3/4 pi. This is pi. You know, I'm going to go 2 more. So then this will be 1.5 pi, 3 pi over 2 in other words. And this will be 5/4 pi. You know what, I'm going to go back a little ways too. Just get a couple tick marks going there. So we'll go back to negative pi. So that's negative pi over 2, negative pi over 4, and negative 3/4 pi. Okay, looks like we're going to need to go up and down by 2. So I'm going to kind of try to make this one a little bit to scale. So I'm going to say that's 1, and that's 2, and same thing down here. So closer to scale on this one than the last one or two that we've done. All right, you know what? I'm going to switch to a different color. Let's do green for the guide, and then we'll do the actual function in red. Okay, so the guide is going to come along here and be in green. All right, so we're going to start not in the middle, because that would be the way you do it for sine, but cosine starts up, except this is negative cosine, so it's going to start down. And then, in addition to starting down, we're supposed to go to the right by pi over 4. So I believe this is the first point on the guide. So I did that, right? I did that. I haven't done this yet, but I've done the 2, and I've done the cosine. So I think I'm good to go, except I need to now end that wave at pi over 2 away. So pi over 2 away is going to be at 3/4, and then pi over 2 away from that will be at 5/4. Now that doesn't look perfect, but I think that's because of my inappropriate spacing up here. So then in the middle at 1/2 I'll be up at the top, and in the middle at pi I'll be up at the top. And let's go one more this way as well. So now I can just kind of use my dots to position myself. So that means this must be back here, and this must be up here on the y-axis. All right, so let's draw our guide in there. I'll do my best with my new tablet. I don't know how good it's going to go, so let's see. There we go, and come down, and go up. Oop, made that one a little bit too much, but that's okay. And so forth. And then this guy's got to go up to the y-intercept, and come back down. Right there. Okay, so there we go with our guide. Now we actually need to get our secant function in there. So remember, the key to that is to draw your asymptotes through your x-intercepts. Your x-intercepts in some cases might have been moved if you had like an up or down, like if you had a +3 out here. So then it'd be looking at where they intersected the line y = 3. But that we don't have in this case, so my x-intercepts are like right here, and so forth. You don't have to go by that. You just need to surround the peaks and valleys. That's another way that I like to think about it. Okay, so I'm going to try to draw some asymptotes in here as best I can. And there we go. And here we go. And so forth. So you can see I'm surrounding the peaks and valleys, also targeting the x-intercepts. Whichever way you like is best for you. You should label a couple of these definitely. So this should be right in the middle. So instead of pi over 4, I think that one's at pi over 8. And the next one is between 1/4 and 1/2. If you know anything about woodworking or metalworking, that's 3/8. So this looks like it's going to be at 5/8. You can kind of spot the pattern, and 7/8. And so forth. I'm not going to label them all. All right, so then how do you actually draw the actual secant function? Those are, of course, just the asymptotic guides. Remember, the secant function is going to go from the tops and bottoms of the peaks and the valleys. So there's part of the secant. There's another piece of the secant. And together, that and that form one period. So you can see that the secant still has that same period. It's not in the same starting and ending spots, but it still has the same period of 1/2 pi. Remember, these are not actually parabolas. These are actually what I like to call pseudo-parabolas, because they're not really parabolas because they're constrained between asymptotes. So they're fake or pseudo. That's my personal way to describe them anyway. So we got that piece and that piece. And of course, the domain is going to go forever. So if we wanted to write the domain of this function, because I think you're going to need to be able to do that soon enough in class, let's just actually specify the domain since we've got a couple minutes left here. So the domain of this secant function is going to be the set of all x values such that, that's what this little vertical line means, such that you're not a few things. We can't be the asymptotes, so we can't have x being things like down here at pi over 8, right? We can't be pi over 8 or 3 pi over 8 or any of those guys. So we can't be that one. And then the space between those looks like it's going to be 1/4, right? Between 1/8 and 3/8, or between 3/8 and 5/8, that's going to be 1/4. So I'm going to say 1/4 k. And then I'm going to specify where k is any integer. Oh, that's really sloppy. Let me clean that up. Where k is any integer. Okay, sometimes you'll see textbooks or people like me write this a little bit more sophisticatedly where it says k belongs to, that's what that symbol means. And then if you remember the symbol for the set of all integers, it's like a little script Z dude. Okay, so any of those notations are fine, but that says that the set of all x is such that as long as x is not 1/8 or 1/8 plus 1/4, in other words 3/8, or 1/8 plus 2 1/4, in other words 5/8, as long as you're not one of those things, you're good to go, as long as you're not on the asymptote. So that's how you write an infinite domain. I'll see you next time.